Welcome to ChemDoodle Shorts. I'm Mary, your ChemDoodle Pro. Let's learn about VSEPR theory and the octahedral geometry. VSEPR, which stands for valence shell electron pair repulsion, is a model that predicts the geometry of molecules based on the valence shell electrons about a central atom. The electron pairs and bonds, or lone pairs, repel one another to maximize their distance from each other. Let's learn about molecular geometries when there are 6 domains of high electron density about the central atom. As seen here, sulfur hexafluoride has a central sulfur atom surrounded by 6 fluorine atoms. To minimize electrostatic repulsions, it arranges into an octahedral molecular geometry. There is a fluorine atom oriented upward, another one downward, and 4 are in the plane of the sulfur atom. What are the bond angles in an octahedral molecule? To measure an angle in ChemDoodle 3D, select Measure Angle in the Measurements palette. Then select the 3 atoms and/or electrons that make up the angle of interest. Be sure the second selection is the vertex. In the octahedral shape, all bond angles are 90 degrees. Let's see what happens when one of the atoms is a lone pair. In bromine pentafluoride, bromine is a central atom. There are 5 atoms of fluorine bonded to the central bromine atom and a lone pair, so there are 6 total domains of high electron density. To maximize their distance from each other, VSEPR theory predicts that bromine pentafluoride adopts an octahedral basis with a square pyramidal molecular geometry. Notice how the 4 fluorine atoms in the same plane as the bromine atom form a square base, with the 5th fluorine atom forming the apex of the pyramid. Hence the name square pyramidal. Similar to the octahedral molecular geometry, the bond angles in the square pyramidal shape are 90 degrees. Let's consider a molecule with 2 lone pairs. Xenon Tetrafluoride has a central xenon atom with 4 fluorine atoms attached and 2 lone pairs, for a total of 6 regions of high electron density. As such, VSEPR theory predicts that xenon tetrafluoride will arrange into an octahedral basis with a square planar molecular geometry. In the square planar shape, the 2 lone pairs are positioned on opposite sides of the central xenon atom to maximize their distance from each other. Meanwhile, the 4 fluorine atoms are in the same plane as the xenon atom, forming a flat square about the central atom. Hence the name square planar. All bond angles in this geometry are 90 degrees. While other molecular geometries, such as T-shape and linear, are predicted for molecules with 3 or more lone pairs on the central atom, these types of molecules are rare. In VSEPR theory, when there are 6 domains of high electron density, the most commonly predicted molecular geometries are octahedral, square pyramidal, and square planar. Thanks for watching ChemDoodle Shorts.